Welcome back to our part 3 installment of our January 2019 Regents review. We're going through now questions 18 through 24, finishing up the multiple choice of the Regents. We got 7 problems to do. And in the next part, we're going to go through the part 2s and part 3s for this January 2019 Regents. You're just copying on the answers, as I said before. If you're just copying on the answers, you're not learning. So please, you're not just trying to get to the right answer. You're trying to find out the right way to get to the right answer. You're trying to pick up the right skills to get to the answer, all right? So, feel free. That's why I'm doing a video, right? So that you can pause me, you can make me shut up, and you can start to think for yourself. And I'll give you those prompts that you can think for yourself on these. And we'll get started, all right? So let's do this. All right, question 18. Question 18. Which pair of equations would have the coordinates -1, comma 2 as the solution? All right, so we're looking for the pair, the two equations that would both have this as a solution. All right, hopefully, pause this video. Oh yeah, before I get going, pause this video here and see what you can do. See if you can guess what it might be. Take a shot, multiple choice. Think about it. Give it some thought. Don't just do a random answer. Apply your mind. See what you got. See if there's anything here. Sorry, I should stop talking. Pause me. All right. Here we go. So hopefully you should know this is the x coordinate and this is the y coordinate. All right. You need to know that. You need to be able to know that what your coordinate points are. I'm sorry, I'm making sure we're in focus here. So I need to find when I plug in -1 as the x variable and when I plug in 2 as the y variable, this should be true. So I have an equation here that says y equals x plus 3. So does 2 equal, so y is 2, because it says y equals x plus 3. X is -1 plus 3. Does 2 equal -1 plus 3? Yes, it does, right? Because -1 plus 3 is 2. 2 equals 2. Well, this part checks. So far, so good. Does y equal 2 to the x power? So our y value is 2. Does 2 equal 2 to the power of x? X is -1. Okay? 2. Now, unless you're in my Algebra 2 class, you haven't done negative exponents. So let your calculator figure this out for you. 2 caret. I'll make sure I want you to see what buttons I'm pressing. I pressed 2 caret. It's this little up arrow button. This little up arrow button is called the caret button. When I press this button, it will raise it. It will raise it to the exponent. It will raise it to the level of some exponent I put in here, and I'm going to put -1 in there. All right. When I put in 2 to the -1 in my calculator, I pressed enter. It gave me 0.5. Is 2 equal to 1/2? Is 2 equal to 0.5? No. So choice number 1 doesn't work. All right. Choice number 1 doesn't work. Let's see. Y equals x minus 1. All right. My y value is 2. My x value is -1 minus 1. All right. Does 2 equal -1 minus 1? That's -1 minus 1 is -2. All right. If you don't know that, put that in your calculator and find out. Does 2 equal -2? No, of course it doesn't. So right now I can eliminate choice number 2 right here. Choice number 3. Y equals x squared minus 3x minus 2. Woo! All right. I can do this, though. I can do this. Does 2 equal x squared? My x is my -1, so -1 squared minus 3 times -1 minus 2. I think I'd recommend that you put this in your calculator. All right. I recommend using these parentheses, -1 squared. Oh, make sure you can see all the buttons I'm pressing. So I put -1 in parentheses. It's important to put your negatives in parentheses. Squared, I press the x to the second power button, minus 3 times -1 minus 2. I'm going to press enter and see if this equals 2. It does equal 2. All right. So far so good. Does also y equal 4x plus 6? Does 2 is our y value, equal 4 times our x value, -1, negative 1 plus 6. All right, little technical error there. 2 does 2 equal 4 times negative 1 plus 6. Now maybe you want to use a calculator, figure this out. Maybe you can do this in your head. 4 times negative 1 is negative 4. Negative 4 plus 6 is 2. That works. That works. All right. So we have an answer actually. We have number 3 can be our answer. We found using our calculator that 2 times negative 4 plus 6 is 2. And we also used our calculator to find that, let's see, negative 1, oh, sorry, what the y equals. I'm trying to write that in there. All right. I'm trying to look for enough space to write this. 2 equals, that's y equals. Y is 2 in this case. It's going to be negative 1 squared minus 3 times negative 1, minus 2. We did that in our calculator. We found that equals 2. So 3 is going to be the obvious choice to go with here. And if you weren't sure, you can go with choice 4 and plug in your variables here. You can say, okay, let me test this one out. 2x plus 3y equals negative 4. Is that true? 2 times my x value is negative 1. There's my negative 1 in parentheses. Plus 3 times 2. My y value is 2 in this case. Does this equal 4? Negative 4? No, it doesn't equal. Negative 4 equals positive 4. So I would cross out negative 4 as an option here. That's not a solution to that equation, and I can move on. I would give this a medium difficulty. I would give this question a medium difficulty because you really have to test first of all, you have to know that this coordinate point, this is going to be your x value for all these equations, and that's going to be your y value. I feel that part should be easy, but then you got to plug these numbers in and evaluate all these different equations, and you're testing for where this makes sense. Where does this work? And that takes some work, and some mistakes can be made, and so that's why I would give this a medium difficulty. There's some work to be done here. Your calculator, although, is a great tool for evaluating these functions. Plug your x and y values in and see if the equation works. As long as you use your parentheses appropriately, as I'm showing you, the calculator, again, it's a kind of a dumb machine. It only knows exactly what you put in there, so you have to do some of the interpretation yourself. But it's a very useful machine if you use it properly. All right, question number 19 here. Question number 19. Which function could be used to represent the sequence 8, 20, 50, 125, 312.5, given that a to 1 equals 8? All right. Looking at this problem, I'm going to give this kind of a... This is not an easy one. I got to be honest. This is not an easy one. It's not obvious. Pause here and see if you can find a common factor. You're looking for how did this thing go from 8 to 20, from 20 to 50, from 50 to 125? What's happening to this sequence? All right. Try to find out if you can find the function rule. Pause here and see if you can find it. Play around with these numbers. It's okay if it's hard. It's not easy. All right, hopefully you've unpaused it here. Okay, let's play around with these numbers. Let's play around with some of these numbers here. 20 minus 8, that's 12. Okay, so I know the difference between 20 and 8 is 12. The difference between 50 and 20, I can probably do that in my head. That's 30. But just to show you, okay. So I know I'm not dealing with a linear sequence. This is not an arithmetic sequence. I'm not increasing by the same amount each time. So I'm going to look for a geometric sequence now. Now we did do arithmetic and geometric sequences before, but I didn't show you this notation that they're using here. So you're going to have to try to make some inferences unless you had a full year of algebra before and you remember someone teaching you I skipped the sequences unit because we did the other kinds. We did the arithmetic and geometric sequences in our functions unit, but we didn't use the sequence notation. So unfortunately, with half a year of Algebra 1 review, some things are skipped over. So 20 divided by 8. 20 divided by 8 is 2.5. All right. 50 divided by 20 is also 2.5. Oh, wait a minute. I'm seeing a commonality here already. What's 50 divided by 125? 125 divided by 50. 125 divided by 50. Oh, 2.5 again. Oh, okay. So let me test this theory. My theory is that this is being multiplied by 2.5. What is 8 times 2.5? Oh, that's 20. What's 20 times 2.5? Oh, that's 50. 8 times 2.5 is 20. 20 times 2.5 is 50. 50 times 2.5 is 125. I bet you 125 times 2.5 gives me 312. Right? I'm sorry, 312.5, right? So now we begin to see that where the sequence is going. So they're telling us that the A of 1, or the A of 1, or ace of 1, is 8. So now my ace of 2 is 20. My A of 3 is 50. That's the third sequence. My A of 4 is 125. My A of 5 is going to be equal to 312.5. And we got to figure out which one of these works. So knowing very little about sequences, but remembering our characteristics of geometric functions, hopefully you could start playing around with some of these numbers, and you could say, well, you could start taking 20 divided by 8, 50 divided by 20. You could start to see that, okay, you're increasing by 2.5. There's a multiplier of 2.5 for every moment in the sequence. Which one of these sequences do I have available to me is multiplying this by 2.5 each time? And as you can see, it's choice number 2 over here is multiplying a to a number minus 1. So it's basically saying take your previous number and then multiply that by 2.5 to get the next number in the sequence. That's how you read this sequence notation here. I'm going to give that a difficulty of medium to hard for question 19 here. Hard because I didn't go over sequences with you. I didn't show you this notation. It's completely unfamiliar to you. That's just the limitations of doing a half a year of Algebra 1 review. But I'm going to do a medium because it's not easy to see what the geometric sequence is going to be. It's easy to know it's not increasing arithmetically. It's not a linear function sequence. But unless you know to take 20 divided by 8 and then 50 divided by 20 and then confirm this as keeps being 2.5 as a multiplier, 2.5, I mean, like, I'm not going to look at this and say, I didn't look at this and immediately say it's 2.5. I had to figure it out and puzzle it out myself. So medium to hard on this one. You know, if this one seems confusing, have no fear. You know, this is one that made me think too. All right, we did do one day on literal equations. All right, and we kind of moved on because I wasn't sure what the value of continuing more than a day on literal equations are. But here we have a literal equation problem. All right, the formula for electrical power P is P equals I to the second power times R, where I is the current and R is the resistance. The formula for I in terms of P and R is, so what this question wants you to do, it wants you to rearrange this original equation, P equals the current the electrical power equals the current squared times the resistance. It wants you to put this in terms of P and R, which means it wants you to rearrange the equation so that it's I equals something. And notice how all your options are I equals something. So you need to rearrange the original equation using all the same techniques that we use. It's all the same techniques, but you're used to having numbers in there, and once the numbers are gone, sometimes students get confused. It's just like when we do geometry without numbers. I know you know that 5 equals 5, but sometimes it's hard for you to realize that the length of AB is congruent to the length of AB to be a reflexive property. Sometimes that throws people off. It's obvious once you understand it, but it takes some, you gotta readjust your whole manner of thinking for this to start to make sense. You need to really think and apply your mind. And then actually that's this whole idea of creating new pathways, of creating new ways to access the same information. So let me write this out. P equals I squared equal, times R, no equal sign. times r. Okay. I want to get this so that I have I on one side, and I want P and R all on the other side. So it's going to be I equals P and R. It's going to be the same equation in terms of P and R. Okay. Now, you've done some of this. I mean, I know that sounds scary, but I have I squared times R. I want to get P and R on the same side of this equation. So if I have this times R, to move R to the other side of my equation, I'm going to need to divide by R, right? If I have something times 5 on one side of my equation, I would divide by 5 on both sides of the equation to move that 5 over to the other side. You've done this before, but you usually do it in terms of numbers, and sometimes we get confused when we're not doing the same thing we're used to doing when it's just variables. This is called literal equations. Okay, so now I know that I squared equals P divided by R. Well, how do I undo, I want to get I by itself. Now, I don't have I by itself, I have I squared by itself. I want to undo squaring something to the second power, or raising some I to the second power. How do I undo something raised to the second power? Think about this. Pause if you need a moment. Don't take more than 10 seconds to think about this. Hopefully you've unpaused at this moment. You thought about it, and hopefully you said, well, 5 times 5 is 5 to the second power. 5 to the second power is 25. And the square root of 25 brings me back to 5. 5 squared gives me 25. The square root of 25 brings me back to 5. So squaring something and square rooting something are inverse operations. They cancel each other. So this is what we're going to do. We're going to square root this side. We're going to square root this side. I squared, the square root of I squared is just I by itself. But now I'm left with P divided by R. Do I have an option that says I equals the square root of P divided by R? Oh, yes, I do. Oh, yes, I do. I'm going to give that a medium difficulty, just because literal equations are not easy for most students. And there's some playing around there. You have to be comfortable with literal equations, and you then have to also know about use the divide by R here to get R to come up on the other side, right? To get the multiplying by R to cancel. And then you also have to know that the square root cancels squaring something. Medium difficulty. Medium difficulty. They're not making these Regents as easy, right? Are they? We don't see very many easy questions. All right. Okay. The functions f of x, q of x, and p of x are shown below. Here's my f of x. It's a line, linear function. Here's my q of x. This could be a quadratic. And here's p of x. I'm looking at this, kind of thinking even as I look at this, I'm thinking I'm probably looking at a quadratic here, right? I'm going from 5 to 4, I'm going down. From 4 to 3, I'm going down. But then 3 to 4, I'm going back up. And then 4 to 5, I'm going back up. Wait a minute. I'm going up by regular intervals. So I'm not dealing with a quadratic. I'm dealing with a absolute value function, aren't I? Okay. When the input is 4, which functions have the same output value? When the input is 4, which functions have the same output value? Okay, pause the video. I hope you can do this. I think you can. I think you've got this. Look for when 4 is the input, which ones of these have the same output? Pause. All right, you've unpaused because you've done something, right? You found at least some of these. The first one's pretty easy. When my input is 4, what's my output? When my x value is my input, when my x value is 4, what is my output? When my x value is 4, my output is 3. That's what this function tells me. When my input is 4, my output is 3. Let's see. Tables are real easy to do this with. When my input value is 4, my y value, my p of x value, my output is 3. Oh, okay. Well, functions f of x and q of x are are going to cross at this point here. And then what about, P of x. What about Q of x? I'm going to have to do this when, my input value is 4. So my input value is 4. 4 minus 1 squared minus 6. Now you can do this on your calculator. That's fine. That's why you have the wonderful tools that we have. 4 minus 1, putting it in parentheses, pressing the x squared button to raise it to the second power, and minus 6. What does that equal? That equals 3. Let me kind of do this out loud in my head. I'm going to trust the computer. I'm going to trust the calculator, though. 4 minus 1 is 2. Remember, I do what's in parentheses first. 4 minus 1 is, sorry, did I say 2? 4 minus 1 is 3. Okay. Woohoo. 3 squared is 9. Woo. All right. Got to do my exponents next. So 3 squared is 9, and then 9 minus 6 is 3. 3. Oh, so they all the same, right? Output's 3, output's 3, output's 3. When the input is 4 for each one of these functions, the output is 3. So choice number 4, right? F of x, Q of x, and the P of x all have the same output for when the input is 4. I want to say that's an easy to medium one. The table evaluating the f of x and the p of x should be pretty easy. I mean, you're literally just kind of say, okay, when the x is 4, where am I at on my y value? When, oh, you can't see what I'm doing. And then here it's right in the answer right there. Of course, you have to know how to evaluate these using a graph and a table. But we spent so much time on equivalent representations. I'm hoping at least those two are easy. This part is the harder part, right? You need to either use but you can use your calculator, and I feel like that would be a pretty easy way of finding that out. But if you did it in your head, then slightly difficult, a medium difficulty if you're writing this out and doing it without the calculator. All right. So easy to medium. I wouldn't call that a give me by any chance, by any stretch of the imagination, but that's not too bad. That's not too bad. Using the substitution method, Vito is solving the following systems of equations algebraically. Oh, systems of equations. We did some of these. We spent 3 or 4 days on systems of equations, but they're not easy. They're not easy. Remember, these are the ones that take like, a half page sometimes. Which equivalent equation could Vito use? All right. Oh, maybe we don't have to do too much work here. Let's take a look. Pause the video here and see what you can come up with. All right. We learned there are 2 basic methods for solving systems of equations. We learned the elimination method, and we learned the substitution method. In a problem like this, you could do either one. You could do either one. I tend to like elimination, and I tend not to like substitution. But this is one of those cases where they want you to kind of have more familiarity with the substitution thing. Let me write this out. So I have this first equation. Y plus 3x equals negative 4. Okay? What they kind of want you to see here is that you can get y to be by itself fairly easily. Notice how all the answers here have all x's. There's no more y's anymore. That's a tip-off to say that they want you to go about solving this kind of problem using the substitution method because they're going to substitute y equals for another expression. And this is the more obvious one they would do. But again, this requires you to have some familiarity with systems of equations, to have a pretty good grasp on systems of equations, and for you to realize using the options they gave you that substitution is going to happen, and then for you then to realize which one of these equations they're doing this with. Let me see if there's any tip-off that what one they're doing with it. Okay, so notice there's a 2 in front of each one of these, which probably indicates to you that they're using this as the base equation. And there's also this negative 3. So notice that there's a 2 here, and that there is 3's here, okay? There's 2 x's here, and there's 3's here. So this should be a tip-off. They're trying to get you to use the base equation. And then so this is the equation they're going to use to substitute 4. Let's continue. Sorry, every time I shake my table, I know my camera kind of wiggles. All right, they want you to know to minus 3x here to minus 3x here, which will get you the expression y equals negative 3x minus 4. All right. Now, I don't think that's immediately obvious. This required me to look and think, and I scratched my head for about a minute. I'm like, okay, what's this doing? Maybe, and then it came to me, but it may not come to you that easily. It may not come to you that easily. You may have to kind of think a little bit longer, and you might have to manipulate some things and just start, kind of coming up with some ideas to go at this. I'll think about this if there's an easier way to go about it, because for me, this was just I kind of had to stare at it and kind of think about what's going on. And when I realized this was the base equation, given the options they're allowing me, then I realized I had to manipulate this top equation, and I realized that y was kind of by itself over here, which made that pretty easy to substitute for. So knew I had to change this equation to this right here. I don't know of a better way for me to explain my thinking for why I did this. But once you get here, it's not too tough. Once you know that y equals negative 3x minus 4, wherever you see a y in your base equation, you're going to substitute the expression negative 3x minus 4, right? If you know that y equals negative 3x minus 4, then you can substitute negative 3x minus 4 in for y wherever you see it. So if I was going to substitute it in, I would write 2 times x minus 3 times the expression negative 3x minus 4 should equal 21, right? If I know that y equals negative 3x minus 4, and I know that 2 times x minus 3y equals negative 21, then I take the 3x minus 4, I substitute it in for y in this equation. I then would have to distribute and say 2x negative 3 times negative 3x is positive 9x, positive 12 equals 21. But we don't have to do all that. We don't have to solve for x here. They're not asking for that. What you have to recognize is that we have to find the problem that's given us this right here. And it's right here. Choice number 3. Choice number 3 has 2x, minus 3, negative 3x, minus 4, equals negative 21. Negative 21. I should have a negative in front of here. If I was gonna solve for x there, I would have made an error because I forgot to bring my negative over. Okay. I'm gonna say that one's in the neighborhood of hard. Okay. I don't want to portray that one as an easy one because it's even hard for me to explain what I'm thinking as I'm doing this one. It's a systems of equations problem. You have to have some if you're familiar with systems of equations, it's a piece of cake, but I know the systems of equation is not easy for many of us. So this one's in the neighborhood of hard, right? I'm still racking my brain, like maybe there's an easier way to explain this. I'm not sure. I'll continue to work on this, and hopefully we'll get more familiar with our systems of equations. But that one wasn't an easy one. So if you didn't do well on that one, don't beat yourself up too hard, right? Oh my gosh, is that our last one? That was question 22. Do we have no more multiple choice questions? Let me pause, hold on. No, there's more multiple choice questions. Sorry to disappoint. There's two more to do, all right? All right, question number 23. Materials A and B decay over time. The function for the amount of material A is represented as the equation the A of T equals 1,000 times 0.5 raised to the power of 2 to the T. Woo! And the amount of material B is the B of T equals 1,000 times 0.25 raised to the T, where T represent the time in days. On which day will the amounts of material be equal? Okay. Pause here and think about what do you know. Write down anything you know. Think about any way you know to go about this thing, all right? We need to brainstorm here. This is the moment we need to use all of our tools and skills. Pause it here. All right, you've paused. You've thought. You've said, what am I going to do? What am I going to do? Okay. Well, we have a tool here, right? We have two. They've given us two equations. So let's go to our calculator. They told us that the first equation is 1,000 times 0.5 to raise to the power of 2 times the variable t. I'm just going to give the variable x here, right? It's easier in my calculator to call variables x when available. I'm going to go, I kind of messed this up, didn't I? Well, I didn't mess it up really, but I put these out of order than I normally would. That's all right. I'll put the b of t up on top. We just have to remember that the b of t in this case is on the y1 section. Oh, what the heck? I'll just do it over again. 1,000 raised to the power 0.5 raised to the power of, making sure you can see everything I'm doing. Raised, if I want you to see everything I'm doing, I have to start from the beginning, don't I? Times 0.5. So far, hopefully, we're pretty good on 1,000 times 0.5. Raised to the power of, I'm pressing the caret button. I'm going to put 2. I'm going to put x. All right, 2x. There we go. Now I'm going to go down to my next equation. 1,000, it's pretty easy, times, parentheses, 0.25, raised to the power of x. All right, now I could graph this. These are going to be exponential functions. I hope you realize that. I don't know if they're going to show up on a nice place on my graph. Okay, there's one. Let me see what the second one's going to shoot. Oh, wow, these lay on top of each other. Ooh, we just found out these functions lay on top of each other. Let's go to our table and confirm this. Go to our table and confirm this. Oh, look at that. Do you see what I'm seeing? These numbers are all the same. When x is 0, y is 1,000. When x is 0, y2 is 1,000. When x is 1, y1 is 250. When x is 1, y2 is 250. These two functions lie on top of each other. That's very good information. Once I've got that, which one of my options does it asks, on which day will the amount of material be equal? What do you think? Do you see the answer? Every day, right? It's the same amount of material every day. On the first day, when we begin this function, they both start at 1,000 pounds or 1,000 grams or whatever 1,000 unit equals. And they're decreasing by these two functions. These two functions lay on top of each other. Therefore, after, are we talking about days or hours? It's days, time in days. So after the first day, they're both 250 grams or pounds or, I don't see a unit of weight that's being measured in here in mass. And then it goes down to, 62.5 whatever units of mass on the second day, and they're both 15 point, some crazy number. So these two functions lay on top of each other. I hesitate to say this one's easy, but I also hesitate to say it's medium either, because your calculator can do these if you're careful with it. It's really only the only difficult part about this is interpreting the results of the calculator. So we might give this a medium, on the easy side of medium. It's a systems of equations problem, but our calculator does most of the work for us. If I was to do this by hand, I'd start plugging numbers in. Like I would plug in when the t is 1 and find out what that is for both these equations, and find out when the t is 2 for both these equations. And when I see that the t of 1, the t of 2, and the t of 3 are all the same, I'm just going to assume that these functions lay on top of each other because 3 points on an exponential lay on top of each other. Okay. Last multiple choice question. The following conversion was done correctly. Okay. I did 1 day on these conversions. I wish I did more. This is kind of so important, especially for science. But you just never know what the Regents is going to have, what it's not going to have. And, we're trying to do Algebra 1 review in half a year. So 1 day was spent. Hopefully that was good, but it might not be. So let's take a look. The following conversion was done correctly. Okay, 3 miles in 1 hour. That's 3 miles an hour. 1 hour in 60 minutes. Okay, yes, there's 60 minutes in an hour, right? there is 5,250 feet in 1 mile. That's true. Hopefully you knew that there's 5,250 feet in 1 mile. You don't have to have that memorized, but that's just something useful to know in life sometimes. And hopefully you know that there are 12 inches in 1 foot. Again, yeah, maybe if you're not sure, you look at a ruler, but hopefully you know that there are 12 inches in 1 foot. What were the final units for this conversion? Feet per minute, minutes per inch, feet per minute, or inches per minute. Take a guess on this. Pause the video here and see what you come up with. So, I mean, I feel like this one's is kind of so easy that it's tricky. Like you're going to doubt yourself. You know, it says, what were the final units in this conversion? Well, the final was the ones at the end. What is this thing doing? What is this conversion doing? It's trying to convert 3 miles an hour into how many, you know, how many inches per you know, minute type of thing. You know what I mean? It's trying to convert. Let's cancel all these things out and see what it's trying to convert into, right? 3 miles gets canceled by this mile unit over here, okay? You see what I'm doing there? The 3 miles divided by miles cancels. Now the 3 over 1 stays. 3 over 1 stays. The hour divided by the hour cancels itself. So I'm canceling my hour units. The 1 over 1 stays. Let's see. Feet and foot cancel. Feet and foot cancel. So I'm canceling my units. So what's left over? I've got inches per minute. That's the final unit, inches per minute. That's the choice I want to select because that's the final units that don't get canceled in this whole thing, inches per minute. And so you're just looking for, okay, so I have miles over here. Where do I have miles? Okay, this mile can cancel that mile. This hour cancels that hour. This feet unit cancels that foot unit. What are my final, what is this whole big thing? What's the final units this thing converts into? It converts into inches divided by minutes. That's the only thing that didn't get canceled. I feel like that's an easy one, except that we're not usually very comfortable with unit conversions and this kind of thing. For some reason, these are tricky for students. I don't, but I feel like they're in the neighborhood of easy, so maybe an easy to medium question. Easy to medium question after you understand how to do it. If you don't understand how to do it, then it's more medium to hard, right? Okay, that is the limit of our multiple choice for the Regents 2019. Hope you enjoyed going through a Regents, feeling a little bit more confidence. Again, the purpose of these is to make it so that you don't feel that the Regents is so scary. I want you to know that you do have the tools. You just don't, you don't know that you have the tools yet. You do need to think and brainstorm, and you know, when you don't know what to do, think about all the things that you do know. Write down all the things you can do. Try some things. Throw some things at the wall and see what sticks sometimes. All right. But we'll go over these in class. I just wanted to make sure these videos so that you had this as an access of an explanation for these ones that you didn't know. And we'll go over the part 2s and part 3s in class. All right. Until next time.